Good afternoon and welcome back to the Army's Artificial Intelligence Integration Center podcast. I'm Lieutenant Colonel David Paddock, and I'm once again your host. In our first two episodes, we established what AI is and how it works, what its limitations are. And today we're addressing the question that every leader really needs to be asking themselves, which is, why does AI matter to the Army right now? Joining me today is Captain Adam Patula. He's a technical expert here at AI2C, and he's going to help connect these concepts to the real world, talk about how they're going to be impacting operation, logistics, training, and the competitive landscape. Adam, it's great to be here with you today. Can you tell us a little bit about yourself, your education background, and how you came to be here?
All right, thank you. Yeah, it's a pleasure to be here on the podcast today. So again, Captain Adam Patula. I am a developer here at the Army's Artificial Intelligence Integration Center. I have an undergraduate degree from West Point in electrical engineering. I became an engineer officer in the Army and served as a platoon leader and executive officer in the engineers before doing the AI Scholars Program and transitioning to work at AI2C. I'm happy to talk about AI and its applications within the Army.
So let's start off with the big strategic question. What is the urgency behind AI adoption, and why is it suddenly such a non-negotiable topic?
I think that it comes down to one word: speed. The modern battlefield is moving faster than human decision cycles can keep up with. We're facing threats that operate at machine speed: autonomous drones, AI-guided missiles, networked air defense systems that can detect and engage in seconds. The key thing there is that we are using computers. We are speeding up the rate at which we can perform thousands, millions of calculations, and we're able to look at millions, billions of data points within seconds, things that humans just can't consume.
So the speed of operations is something that's always impacted the military. And we've been through these evolutions before, right? It started off with radio communications. You no longer needed to have a courier. We moved forward into the digital age. We had the internet and the ability to quickly transfer large files, large documents. But AI is being treated very differently. When we talk about speed, we're not just talking about speed of transition, it's really the processing speed that it brings to it, or is it something different?
I think that it's the processing speed and really the ability to recognize things like patterns in very, very large quantities of data. Like you said, we have all of these human-driven processes that we have incorporated in the past, and those aren't going away. Speed of computation and just the sheer volume of data that's being processed is different.
So when you talk about data processing, as a logistics officer, I think about data and I think about the massive amount of data that's available in the sustainment world. But we collect a lot of other data through, for example, our various intelligence apparatuses. Can you give an example of what that speed advantage looks like when we're talking about data processing with artificial intelligence?
Yes, I think that the example that I'll dive into is targeting. The traditional targeting cycle, humans have to gather intelligence, we collect imagery, signal processing, we build target packages, that gets routed up the chain of command for approval, and then we execute. Take hours to days, depending on the operation, the analyst, the types of data feeds that are coming in. With machine learning and artificial intelligence, we can analyze elements within imagery. We can identify specific targets within them much more quickly and over a larger quantity of imagery than any analyst can possibly do within a given amount of time. And that will significantly speed up elements of that targeting process, taking you from identification to execution, maybe minutes to hours instead of hours to days.
So in that way, it's really a staff tool that is used to provide either a quicker, a better, or a more accurate staff estimate to the commander's decision process.
Yes, I would agree with that. Really, it comes down to now, because you have the time to focus on analysis in critical thinking, you you are better informed by all of the data that's been analyzed by AI and machine learning to make those decisions.
So the staff is now going through a process. They're going to develop a more robust product or a more accurate product or a product at a much faster rate of speed, enabling the commander to make more decisions, faster decisions, better decisions, but still retaining decision authority at the appropriate echelon. Applicable within the offensive targeting operations, or is there a broader spectrum?
No, I definitely think we're looking at a broader spectrum of warfighting functions that are going to be affected. We just spoke about targeting. We can talk about protection. We can talk about logistics. I think that data processing and then machine learning and AI fueled analysis of that data can affect really any discipline.
It also seems like when we have these powerful tools available, that the staff is going to have a reduced workload because they're now managing a system or a model that is doing the heavy analytical lifting. What are some of the impacts of that workload reduction?
Yeah, so I think that again, I'll go back to the targeting cycle and maybe specifically collection management process that fuels it. We're going from the collection of thousands of images to an analyst having to look at those images, then identify specific targets within them. You will have a machine learning model, a vision model that flags important images that allow an analyst to devote their very valuable time to looking at things that have already been identified as important. And at that point, that's where the human critical thinking element comes in. They can look at what the computer's saying, and then they can take their own expertise, their training, and they can say, okay, these things are important. All of that is happening much more quickly. It can be a much more comprehensive report that is then given into the collection management.
So it's a collaborative tool that's going to be doing a lot of the lifting and carrying a lot of that analytical load, but it's then providing back options, decisions, recommendations to users within that staff who've been able to refine those into courses of action for the commander.
Yes, I definitely think so. I would think of AI as more of a collaborative partner. You're going to take a lot of monotonous work out of an analyst's hands. You're going to reduce their cognitive load. And AI and human collaboration is going to ultimately drive the Army's processes forward in both the element of speed and the precision.
Well, it seems to me like whenever you remove a highly repetitive, monotonous task, you're going to remove some of the error rate. Anytime that somebody does a monotonous task, you start having an increased risk of missing a detail. You know, they just get into that habit of not seeing it, and so they're not looking for something that may actually be there. Going back to your targeting example, I've read a lot recently how some of the new AI models are allowing us to use additional methods of targeting and identification based off of human behaviors that may be more difficult when you talk about things like gait analysis or pattern of life. Can you talk to me about how AI is able to use that and how the data analytic aspect of the collection processes feeds into that?
Yes, of course.
If we can talk about conceptually how it's being employed.
And I think that the fundamental piece that I think everyone should take away about machine learning and AI really is pattern recognition. In terms of computer vision models, we're able to identify somebody's gait based on subtle patterns. All of this hinges on data collection, whether it's through sensors, through manual data input from humans. But once you have that data, we can use machines to identify those patterns, sometimes in very unique and unexpected ways.
So obviously lots of operational applications. Let's talk about what we spend more time doing, which really is the training for the operations and the simulations for major exercises and major operations. Can you tell me how AI stands to benefit or enhance training simulations?
I think that AI presents an extremely unique opportunity to enhance training and simulation across the force. So we can think about things like augmented reality, VR, all of these other sort of software-based experience have the ability to sort of immerse a soldier into a more realistic training scenario. So you might put on your VR goggles and all of a sudden you're in an urban environment conducting some sort of urban warfare operation. Now, the AI can come into play during that sort of thing by creating AI versions of the OPFOR. It can learn about how the soldier performs during the simulation. If they always attack from the left, then maybe they would encounter more fire from the enemy on the left. So now the soldier needs to learn that they need to assess the situation, and maybe they're going to attack from the right this time. All of these sorts of patterns and the data collection in these environments can go towards creating more realistic and more tailored experiences in training.
So obviously a huge benefit for leaders at the unit level and figuring out how to do training better, how to improve realism. Talk to me a little bit about how we are using AI to support some of these big Army simulations for how we're approaching modernization.
Yeah, so I'll talk about some of the experiments and exercises that I've been a part of in the past in terms of how we have been using AI and machine learning and really data collection to augment training. We're looking at the distribution of net warrior devices to the squad, the platoon level, using each one of those as nodes feeding information back to division, corps level collection sites, putting additional sensors on vehicles, the onboard hardware that tells you information about the health of the vehicle, fuel levels. Once you have that information, particularly in a larger scale training environment, you can start to do some predictive analytics on what sorts of classes of supply you need to stage at certain points that are informed more holistically than some traditional methods.
And when we talk placing sensors, I feel like sensors is such a small word with such a broad application. So that's going to be anything from putting GPS sensors on every vehicle to see where they're maneuvering and capturing their data through regular intervals across a training area. But that can also include things like putting microphones on people who are having a conversation and then capturing those conversations in order to distill out learning patterns or growth. Or as we start figuring out what's important for training these models, can we also start to use some of those conversations to deduce what people think are important when they're having those conversations so that we can train the AI models to prioritize those same types of aspects and issues?
I think that hits the nail on the head, particularly in a military context. A lot of the things that we're seeing in industry on the civilian side, everything's informed by data collection. People will curate exactly what sort of information goes into fueling these models. For example, you wouldn't want to put everything that's on the internet into a large language model. There's a lot of misinformation, disinformation that's out there. There's a lot of things that aren't even coherent text. You would want to curate all of that information and make sure that you only have high quality text that's going in to feed a model. In the military case, if we're talking recorded conversations, if we're talking doctrine, you want to ensure that you're collecting, high quality recordings, you're processing all of the data to essentially tell a story that you want to tell. And at that point, your models that you generate down the line are going to be more reflective of that story as well.
So it seems like the sensors are useful not just for informing decision making for commanders once a model is in place, but they're also a really important way for programmers like yourself to make decisions about how we train these.
And I'll go a step further with that statement and say something like for image collection, if you have an image of a tank, and then the enemy might paint the tank a different color. And at this point, your model might not recognize it anymore as that particular tank. At that point, you would want to have a human involved and say, no, that is the same tank. And then the model will learn to identify the tank of a different color now. It essentially will identify it's the same thing. That's where the human could come in and say, no, this is the direction I want you to go.
So going back to what we were talking about earlier, which is the collaborative environment where the model is going to be providing information back, but keeping those trained analysts or staff officers involved in that process is going to be an important aspect to making sure that the model retains its accuracy over time.
No, absolutely. The advent and the incorporation of AI into Army processes in no way gets rid of the human element. In fact, I would say the human element is even more important. You have an extremely powerful tool, but we need to make sure that our institutional expertise and individual expertise, is involved in shaping the decisions that happen after you get an output from an AI system or model.
So let's pivot for a minute. Earlier, you talked about the benefits of a lot of the AI models in supporting logistics and maintenance, and particularly for improved planning models for logistics and maintenance. So really what you're describing now is an improved diagnostic model, an ability to connect a sensor error to a fault much more effectively based off of a holistic understanding of it. I feel like that could also potentially be used as a cost-saving mechanism in order to reevaluate how and when we do things like routine services on our vehicle. Maybe a vehicle doesn't need services at the same interval based off of its usage history and its current performance based off of its sensors. Are we looking at all into how we can use some of these models to decrease the sustainment costs for vehicles over their lifetime?
Yes, in the past, I was involved on a project that was looking at predictive maintenance for the D6 dozer. We had a lot of D6 dozers in my company's fleet before I came to AI2C. And what we were able to look at is, across the Army, how often certain parts were ordered against the machine itself, how long of a lead time units had when those parts were ordered, what sorts of faults were associated with different parts, deadlining fault, slash fault, that sort of thing. Once we have all that sort of information as well, we can create better servicing plans, like you said. That in itself involves, more deliberately ordering the service kits, how many you need to have on hand, how often it needs to happen. Do certain elements of a service contribute to a decreased number of faults for a particular class of equipment?
So the Army is obviously always trying to maintain the lead on these major transformative technologies like artificial intelligence, but we're not the only ones in the game right now. Can you talk to me about how our development with AI is occurring in a competitive geopolitical landscape?
All of these advances have been happening at an incredibly fast pace. So, of course, our adversaries, China, for example, is looking at decision support system, the development of technologies to enable those, their PLA to industry to support various efforts. And what they're really looking at there is how can AI, machine learning, large scale data processing assist with decision optimization. Another entity like Russia is also pursuing advances in AI-enabled technology. We're seeing a lot of usage of drones within the conflict with Ukraine, particularly in the electronic warfare space, signal processing, that sort of thing. Iran was selling a lot of drones to Russia to use in the Russia-Ukraine conflict. And then North Korea has been working in the cyber attack, particularly in partnership with China. So we've seen advances in those areas across all of these entities. It is important for us to continue our own advances as well.
And I think you hit an interesting point where you talked about Iranian drones being sold to Russia to be used in Ukraine. You know, there's the AI that we're working to develop, but there's also the AI that's being employed right now. Are we starting to capture lessons learned from how those models are being employed to learn what works, what doesn't work?
Yes, and I think that an example here would be in the computer vision space, where you might have a drone that is operating beyond the front line, collecting imagery, particularly in the context of the Russia-Ukraine conflict. You need to get that imagery back to the operator. The operator needs to get that imagery to some sort of tactical server stack, which needs to go by satellite to some sort of cloud infrastructure. And at that point, you need to have the ability to store large amounts of images. You need to have vision models that can identify specific pieces of equipment in those images and then flag them as important, and then route terminals that a human analyst can look at, and then it'll go into the more human-driven staff processes. So all of those elements present unique technical challenges that are also vectors that an adversary could exploit.
And we've really been tasked by the current administration and leadership, not just to embrace it, but really to drive forward and transform the military, not just with the adoption of new systems, but with additional organizational structural changes. Can you talk to me about that a little bit?
Yes, so I think that the first thing that we saw was last year when the acquisitions community was ordered to streamline the acquisitions process for these sorts of technologies. And then more on the Army adoption, the soldier training side, all of these changes are occurring so fast that many individuals who would eventually use these tools in their jobs aren't necessarily receiving the requisite training to truly understand what is going on. And when I say that, I really mean the understanding from a data-centric point of view what a thing is telling you. And I think that that sort of understanding causes an individual to ask different questions about an output that they see on a computer screen. If something is nominated as a target, for example, on a monitor, you should immediately ask what sort of data is backing this? Which model gave me this information? And that sort of training, I think, is going to need to be incorporated more and more in places like IT, Bullock, Wobuck, as a foundational guide to a more data literate force.
That'll be a generational change to impact how we train our service members. I think we've covered a lot of great material today, discussing why AI matters to the Army right now, how it's going to matter into the future, and really talking about the benefits of speed and particularly how it applies to our improvements in efficiency and workload reduction. It's no longer optional. This is what the future of warfare is going to look like, and we are embracing it at the speed of transformation. I thank you, Adam, for being on the podcast today. It's been great having you. I hope that everybody is able to join us for our next episode. We're going to talk about the flip side of this conversation and what leaders can get wrong about AI, some of the misconceptions and pitfalls, and most importantly, we're going to discuss some of the common mistakes that can derail efforts for integrating AI into efforts. I hope everybody will join us for that episode.